Okay, today we're going to talk about arc length of a smooth curve. Today is the 13th. And our topic is arc length of a smooth curve. Okay, so let's start off with the definition of arc length. So we're going to let the function given by y equals f of x represent a smooth curve on the interval from a to b. The arc length of f between a and b is s is equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. And similarly, if we have a function x is equal to g of y, then s is equal to the integral from c to d of the square root of 1 plus g prime of y squared dy. Let's take a look at a couple of examples. Find the arc length of the graph of y is equal natural log of cosine of x from x equals 0 to x is equal to pi over 4. Okay. Alright, so the graph looks a little something like this. Oh, that's awful. But we want the length of the arc from here to here. So we want this length right there. Okay. So we know we need dy dx. So s is equal to the integral from 0 to pi over 4 of square root of 1 plus, now we're going to need f prime of x, or dy dx squared, and then dx. So let's go ahead and find dy dx. If y is equal to the natural log of cosine of x, we know that the derivative of natural log of u is u prime over u. The derivative of cosine is negative sine. So dy dx is going to be negative sine of x over cosine of x, or negative tan x. Dy dx squared is negative tan x squared or just tan squared x. Excuse me. So our arc length formula then becomes s is equal to the integral from 0 to pi over 4 of the square root of 1 plus tan squared x dx. Now you may represent, or you may recognize that 1 plus tan squared x dx represents a Pythagorean trig identity. Remember that 1 plus tan squared x is equal to secant squared x. So we can replace the 1 plus tan squared x with secant squared x. And our arc length integral then becomes the integral from 0 to pi over 4 of the square root of secant squared x dx. Well, the square root of secant squared x is just secant of x. So this then becomes the integral from 0 to pi over 4 of secant x dx. And the integral of secant of x, this is one of the 34 that you guys were asked to memorize. The integral of secant x is natural log secant x plus tan of x. So this is natural log absolute value of secant x plus tan x, and we're going to evaluate that at pi over 4 and 0. So plugging in our values, so this is natural log, let's see, secant of pi over 4 is, well, that's 1 over the cosine of pi over 4, and cosine of pi over 4 is 1 over square root of 2, so secant of pi over 4 is square root of 2. Tangent of pi over 4 is 1, minus natural log, well, secant of 0 is 1, and tangent of 0 is 0, and then natural log of 1 is 0. So our answer is natural log of square root of 2 plus 1. Okay, let's take a look at one last example. Say we have x is equal to 1/3 y squared plus 2 to the 3/2. And we want to find the arc length on the interval y between 0 and 4. Okay. So first thing we need to do is find dx dy, because our arc length is going to be the integral from 0 to 4 of the square root of 1 plus dx dy squared dy. Dx dy is going to be 3/2 times 1/3 y squared plus 2 to the 1/2 times 2y. And let's see, 3 over 3 is 1, 2 over 2 is 1. So we are left with y times y squared plus 2 to the 1/2. Now if we square dx dy, then that's y times y squared plus 2 to the 1/2 squared, and that's going to give us y squared times y squared plus 2, or y to the 4th plus 2y squared. So our arc length, s is equal to the integral from 0 to 4, square root of 1 plus y to the 4th plus 2y squared dy, and then y to the 4th plus 2y squared plus 1 is just y squared plus 1 squared. That's the integral from 0 to 4, the square root of y squared plus 1 quantity squared dy, and the square root of y squared plus 1 quantity squared is just y squared plus 1. Okay. Alright, and taking our antiderivative there, we're going to end up with 1/3 y cubed plus y. We're going to evaluate that at 4 and 0. So that gives us 64 over 3 plus 4, and then minus 0. So 64 over 3 plus 12 over 3, I believe, is 76 over 3. And that should be our answer. You have the rest of the time to finish up this assignment. All 3 assignments from Chapter 7 are due today. So Section 7.1, Section 7.2, yesterday's assignment, and today's assignment, Section 7.4. You can go ahead and staple those, place those in a basket at the end of the 3rd period, and I'll see you tomorrow.